This is section 9.2, talking about quadratic functions again. This is basically just continuing to talk about how we graph them. In the last section, we talked about two of the most basic versions of quadratic functions. This one here, where all you have is an a term, and then how that one, if you remember to the last couple minutes of the video last time, talked about then when you add c to that these two things are very similar, except for that step c either moves this function up if it was a plus c or down if it's a minus c. Okay. Now what we're going to do is we're going to actually put in this b term. We're going to put in that middle b times x to the first power and see what that does to our graph. What we're going to find out is that it actually moves it left and right. Okay. So if we kind of look at these here, we'll go through a little bit of work here to recognize the amount that this gets shifted. Okay, so if we just had just 2x squared, if that's all we were dealing with, the vertex would be at 0, 0. Okay, but now we see that the vertex is actually located at x value of negative 1/2. And the way that happens, if we look at what's going on here, is that what we do is we take the opposite of that number. So it's a positive 2 right now. We're going to take negative 2, and we're going to divide it by 2 times that number. So 2 times that number would be 4. So we get negative 1/2. And that ends up being that number right there. And then to get that number, what we do is we replace, because that's a y value, so we replace this with the negative 1/2 and that with negative 1/2. So if I'll do that, it'll say y equals, so we go 2, be negative 1/2 squared, plus then 2 times negative 1/2. If we do this, so negative 1/2 squared is 1/4. 2 times 1/4 is 1/2. And then this is minus 1. Okay, so 1/2 minus 1 is negative 1/2. And there's your y value. Okay, so what we did here is we took, like I said, we took the opposite of this middle term. So it's going to be opposite of the b term. And then we divide it by 2 times that number right there, and that's the a term, so 2 times a. So let's see if that little formula right there does the same thing over here. So if all I've done here is I used GeoGebra to graph these, cut and paste them out. So this was, you can do it in Desmos. If you could type that in, this is the graph it's going to give you. Let's see if that vertex has the same relationship that this one had. So take the opposite of b, which would be now negative 4, because it's a positive 4 here, over 2 times a, and your a is 2. That's that 2 there. So negative 4 over 4 then gives me negative 1. And that is that value there. The next thing we're going to do is then say, okay, well, if that's the case, then y would be, let's plug that negative 1 in, so it would be 2 times negative 1 squared plus 4 times negative 1. Just plugging it into the x's here. Negative 1 squared is 1, times this 2 would be 2, and then plus 4 times negative 1 turns into negative 4, and that gives me negative 2, which ends up being that value right there. So what we're seeing here is that if we use the opposite of b over 2a, that ends up giving me the x coordinate of the vertex. And if I plug that back in to what I started with, the equation, then I get the y coordinate of the vertex. So let's do it one more time here. So opposite of b, so b is positive 6, so we'll go negative 6 over 2a, so now in this case 2 times a would be 4, so we get negative 3 halves, which is negative 1.5 as a decimal, so you're seeing that there. And then if we go ahead and plug that in, I'll go 2 times negative 3 halves squared. This is why we like fractions. It just makes things a little bit easier to evaluate here. Negative 3 halves squared comes in to become 9 over 4. Okay, so this here is going to be then negative 18 over 2. So this ends up being 18 over 4 minus, then this will be 36 over 4, so it gives me negative 18 over 4. There's a 2 in both those, so I'll divide that out. So we get negative 9 over 2, which is a decimal, is negative 4.5. So that's what's nice here. So continuing the notes through, we see it says, notice each line of symmetry and the x-coordinate of the vertex is located at the opposite of b over 2a. Okay, so that's something to talk about. This, remember, this red dotted line here is the axis of symmetry, meaning that that is the line that we would fold on for that green portion to land on that purple portion. There's some symmetry there. That line of symmetry always passes through the vertex of your parabola. Okay, so, and that's always a vertical line, so that means that that red line there is the equation x equals negative 1/2. This line here would be x equals negative 1. And this line here would be x equals negative 1.5, or 3 halves. So here are the tips that we're going to go through to graph some quadratic functions quickly and accurately. The first thing is to locate the axis of symmetry found by using that little formula. The x value equals the opposite of b over 2a. Number 2 says use the above x coordinate and plug that into the original function to find the y value that goes with it. We already did that. That's what we were doing here. Okay, so we use the opposite of b over 2a to get this negative 1/2, and then we plug the negative 1/2 back in to get the y value. In this case was also negative 1/2. So it gives me the y value that goes with this x value. So now if I pair them as an ordered pair, that gives me the vertex. Okay. Step 3 says now substitute x equals 0 into the function, and that's going to give me what we call our y-intercept, so we're across the y-axis. And we're going to see that eventually that is just y equals c. Okay, when you plug 0 in, everything disappears except for the constant term. So because of that, a quick way to find your y-intercept is just take 0 comma your c value. So I was looking up here, just kind of look at this. Some here, and these are all kind of bland, but my c value here is 0. C value there is 0. The c value there is 0. So if I go off of the ordered pair 0 comma c, well, that would be 0 comma 0 in this case because c is 0. Is that my y-intercept? Did I cross the y-axis at 0? I did. Same thing here. Cross the y-axis is 0. Cross it at 0. What can I show you here though is that, let's say I have y equals a times x squared plus c, something like that. And actually, let's put a bx in here too. So plus bx. All right. So let's kind of move these around. And I'll move the c to. There we go. All right. So here we see if we had the actual equation, we have 3.6 x squared plus, or sorry, these are backwards. Let's move these. So my A, my B, and my C. So it'd be 3.4 x squared plus 3.6 x plus 2. We see that 2 is where we cross the y-axis here. Okay, if I make that go to, let's say, 5, you see again that that's where you cross your y-axis. So these two numbers don't matter at all for where I cross the y-axis. It's just the c term. So if my c term was -2, you see down here that this thing crosses at -2. And to validate or to prove the fact that the a and the b doesn't matter is if I play that and let it oscillate back and forth, you can see that no matter what the a value is, I'm still crossing the y-axis at -2. No matter what the b value is, so now these things are moving all together. Look at all these different parabolas that we could create. They're all still intersecting at -2 as my y-intercept, because that is what my c value is. So that's a key component. Okay. Now that you have that, we can use that point along with the axis of symmetry and reflections in order to find a third point. Once we have those 3 points, we connect the smooth curve and we've got our parabola. So I'm going to go through a couple examples of this with you. So step 1, x equals the opposite of b over 2a. So figure out what that looks like. So x opposite of b. So now in this case, b is -6. The opposite of that would be +6. All over 2a. Well, a is 1, so 2 times 1. So that's going to give me 3. So the x coordinate of my vertex is 3. Okay, that is also the axis of symmetry. Second part says now take that 3 and plug it in to find the vertex. So we'll take, so y will be 3 squared minus 6 times 3 plus 4. So that's y equals, this will be 9 minus 18 plus 4. So 9 minus 18 gives me -9 plus 4 gives me -5. So what that tells me then is that the vertex had an x value of 3 and now a y value of -5. So I'm going to plot that, 3, -5. Okay, so that's my vertex. Okay, now I know that that number right there is positive, so this graph is going to be like that. It's going to be concave up. That's just a nice fact to know, or to use to confirm some work here in a moment. Then the next thing that we're going to do is figure out what my y-intercept is. So your y-intercept, remember, that is when you let x be 0. Okay, so think about this. I have y equals x squared minus 6x plus 4. But I'm going to let x be 0. So we get 0 squared minus 6 times 0 plus 4. Well, 0 squared, that's just 0. That goes away because that's just 0. So we have 0 minus 0 plus 4, obviously just 4. So I get 0 comma 4 as my y-intercept. Is that the same thing? If this is my a term, that's my b term, that's my c term, this point is 0 comma c. I can just pluck that number off, put it right there in an ordered pair, and I'm good to go. So 0, 4 is my y-intercept. Okay, so now this is what we're going to do. We got those 2 points. We know we got our vertex. We know our axis of symmetry is that line right there. Okay, and here's the thing. And this is the purpose of symmetries. That distance right there is 3 units. So when I fold on that dotted line, that's got to be 3 units, and it gives me another point right there, 6 comma 4. Okay, and we can guarantee, validate that maybe by just plugging in. Let's say if I had y equals, okay, so if I chose the value of the x value of 6, it'd be 6 squared minus 6 times 6 plus 4. Well, that's 36. That's also 36. They're being subtracted, so those wipe out. Those are opposites. So it gives me 4. So when x was 6, y was 4. But I think you can see that the symmetry process allows us to get that point maybe a lot quicker than what this algebra does. So now we got those 3 points. All we've got to do is connect with a smooth curve. Sorry about that. Connect the smooth curve, and there is our parabola. Kind of hard to use this tablet to draw parabolas. All right, on to the next one. Same idea. Okay, so first thing, x equals opposite b over 2a. Opposite of b, so there's your b, so the opposite would be negative 6. 2 times a, so that's going to evaluate to give me negative 1. So x equals negative 1 is the axis of symmetry, and it is also the x-coordinate of your vertex. Second step, plug that in to find the y-coordinate of your vertex. So y equals, we go 3 times negative 1 squared plus 6 times negative 1 plus 2. So negative 1 squared is 1 times the 3 out front, so we got 3 here. This is going to turn into minus 6 and then plus 2. So 3 minus 6 is negative 3 plus 2 is negative 1. So my vertex had an x-coordinate of negative 1 and now also a y-coordinate of negative 1. That's your vertex. So negative 1, negative 1. Okay. Next thing I'm going to do, find my y-intercept. Remember, y-intercept is when x equals 0. So we go y equals 3x squared plus 6x plus 2. And what I like to do is I like to say, okay, well, if I'm finding my y-intercept, then x is 0, that goes away, and all you're left with is y equals 2. So x was 0, y is 2. And you get that point. Now let's finish it. So the quick way of finishing this is to get our axis of symmetry here. That distance right there is 1, so when I reflect, I'm going to have to reflect the distance of 1, and I get that point right there. So negative 2, 2 would have been another point that I get out of that thing. But those 3 points now, connecting with a smooth U shape. Mine's kind of stink, but you get the idea. Alright, so do this last one here. Opposite b over 2a, so it'd be negative 2. Okay, 2 times negative 1, so it gives me an x-coordinate of 1. Figure out what the y-coordinate is, so y will equal, so it'd be the opposite of 1 squared plus 2 times 1 minus 5. So this is negative 1, that's 2, and negative 5, so negative 1 plus 2 is 1 minus 5 is negative 4. So your vertex is at x being 1, y being negative 4. Next thing we're going to do is let x equal 0. Remember, this is going to give me my y-intercept. Okay, so and we just do this the shortcut, remember 0 comma c. So we got 0, and what's the c term? C term is negative 5. Where's my y-intercept? So let's graph it. Vertex at 1, negative 4. y-intercept at 0, -5. Okay. Axis of symmetry goes through the vertex. Now if I reflect, that's a distance of 1, so I need a distance of 1 over here. So at that point there. And now this would be my parabola. Remember, we've talked about that being concave down. Okay, that matches that being a negative. When A is negative, it is concave down. Let's do some things that we talked about in the last section. The domain of this, remember, it's a parabola, it's quadratic, so it's all real numbers. The range, that's your y values, and they're the y values that you're actually graphing here. So my first y value I see is -4, and then all these other y values below are less than that. So I'm going to say y is less than or equal to -4. That's my domain and range for those. I'll come back up and do the domain and range of these as well. So here's the domain for this one is all real numbers. Okay, range. Okay, remember drawing that horizontal line and lifting it up. The first y value I get to is -1. And then all the other y values that are plotted throughout here are greater than -1. So I'll say y is greater than or equal to -1. And then here, my domain, again, is all real numbers. And my range is my y value. Okay. First y value I see is -5. And all the other y values are greater than or equal to that. Something you can think about is if it's concave up to figure out your range, it's going to be y is greater than or equal to always. And then it's the y coordinate of your vertex. So concave up, you write that first, and then the y coordinate of your vertex. Does that match this? Okay, concave up, so I write y is greater than or equal to, and then the y coordinate of my vertex. See if how we do this one. Okay, this one's concave down. So now instead of saying greater than or equal to, it's less than or equal to. So y is less than or equal to, but then it's still the y coordinate of your vertex. Okay, so that might be a little trick to always find the range for your parabolas. All right, so these here, I'm just going to go through quickly and help you find the vertex in axis symmetry. This one's kind of a trick. There is no b term here. Okay, so what this means to us is I should rewrite this as y equals 2x squared plus 0x plus 3. So now if I go x equals the opposite of b over 2a, well, the opposite of 0 is 0 over 2 times a. So we get 0 over 4, which is just 0. Then when I plug 0 in, so that's the axis of symmetry goes through 0. That's the x coordinate of my vertex. When I plug 0 in, that goes away, and I'm left with 3. So 0, 3 is my vertex. Okay, and that matches to what we did in section 9.1. Remember, if I just had 2x squared, my vertex would be at 0, 0, but that moves everything up 3 units. So instead of being at 0, 0, it's at 0, 3. Do number 2 here. Again, x is equal to the opposite of b over 2a. So -12 over 2 times -3. So -12 divided by -6 is 2. So that's the x coordinate of my vertex. Okay, something you guys can do, maybe to help you quicken the substitution. We've done this quite a bit. I go -3, plug my 2 in, squared plus 12 times 2 plus 1. So I'm just writing this equation and this function in to Desmo. Instead of putting x in, I put the 2 in, and you see I get 13. So 213. 13 will be the y value of my vertex. X equals 2 is my axis of symmetry here. X equals 0 to my axis symmetry. Number 3, opposite of B would be 9 over 2A. So 2A's would be 6. So that's going to reduce to, they both have a 3 in them, so 3 halves. This is where I think it might make sense to use our substitution here. Even if you want to write it as like 3x squared minus 9x plus 2, and then tell it that you want x to be 3 halves, it will tell you it'll substitute that way. I'm going to leave it as, I'm going to turn it into a fraction, so negative 19/4. So x was 3 halves. Negative 19/4 was the y value that I got back. Okay. Remember, the axis of symmetry is through that point, or that x coordinate. So x equals 3 halves is my axis of symmetry. And the next one, so x equals the opposite of b over 2a again. Opposite of b would be negative 6. 2a would be 12, so negative 1/2. So that's the x coordinate. It's my axis of symmetry as well. So let's just go ahead and see what we get here. 6 goes there, plus 6 there, and then minus 5. And then what do we get? We got negative 1/2. Just plug in x to be negative 1/2. And we get our y value then to evaluate to negative 13 halves. Negative 13 halves. So negative 1/2, negative 13 halves. Axis symmetry, x equals negative 1/2. As you're working in your homework, just pay attention to, obviously we can write that as a decimal. Just pay attention to the directions. Sometimes they say write your ordered pair using fractions, or they might say mixed numbers. They might say decimals. So just be careful and know that a mixed number is not a fraction. Okay, a mixed number is like 3 1/2. The 1/2 is a fraction, but the 3 is a whole number. That's why it's called a mixed number. You got two different things going on here, 2 different types of numbers. Okay, so mixed number is not a fraction. Okay, give 9-2 a shot. If you guys got any questions, please do not hesitate to ask.